Hello everyone. Today we'll be doing the chapter number 5, getting started with Python. So, what is Python? Python is a high-level programming language which helps software engineers and developers in controlling, managing, and testing of the software. There are numerous features of Python, including it being a high-level language and interpreted language. So, the interpreter executes the Python program. It is general purpose, dynamically typed, meaning that we don't have to predefine the variables before choosing them, unlike other languages such as C++. It has a rich library of functions, which are predefined, and easy to understand syntax. There are two modes of Python, the interactive mode and the script mode. As you can see, in the interactive mode shown on the right, the interpreter is directly executing the statement and showing us the result. So 1 plus 2 is 3. We are not saving the result here. But in the script mode, as shown on the left, we have to save it as a .py extension, as you can see over here. And we are printing the result Python keywords. So in Python, keywords are predefined reserve words in the library of language, which is part of the syntax and can't be used as an identifier. I will be coming to the definition of the identifier shortly. So these are the different types of keywords in Python: true, def, if, elif. We would be doing this later in the course. Identifiers. They're basically names given to identify a variable, function, or other entity. Now, there are certain rules for identifiers which we must keep in mind. Firstly, they can't be keywords as shown before, and they can't start with a digit. So, if, as you can see here, if it is mentioned 12 variable or 12 var, that is incorrect. But if we mention the number after the letter, that is acceptable. Also, it can be a combination of various letters, and we can't use special symbols like @, hashtag, etc. Underscore can be used as an identifier. Even if you're writing underscore var 12 here, that would be acceptable. These are the different examples of the acceptable and unacceptable identifiers. Next is variable and literal. A variable in a program is uniquely identified by a name. The variables in Python refers to an object, an item or element that is stored in the memory. Literal is the value stored in a variable and are also called data types. So for example, here we can see that we are defining a variable called message and printing that message. In another case, we are taking a variable called user number, and the value stored 101 here is the literal. Similarly, here keep smiling is the literal, which is the value stored by the variable message. And we get the output as the following. Next, we talk about comments. Comments are used to add remarks and also help for in documentation purposes to help us understand a piece of code. Now, there are two types of comments: single line comments and double line comments. In a single line comment, it begins with the hashtag symbol and is not executed by the interpreter. So as you can see over here, it is mentioned every line of code starts with a hash. So when we are executing or printing this, it is not displayed, but it helps us understand what the line of code is talking about. So for here, it is the total spending on grocery. Similarly, for a double line comment, we begin with three of these symbols and end with three of these symbols. Now, for example, instead of this hash, we could have used these three symbols together here, and we could have ended the code where grocery is written with these three similar symbols. That would have been a double line or multi-line comment. Now, data types. Data types help us identify the type of data values a variable can hold and the operations that can be performed on that data. The different data types in Python include numbers, including integer, floating point, complex, and boolean; sequences, such as strings, lists, tuples, and the following shown above. Now, under numeric data type or numbers, we have the integer, which is pretty much every real number from it can be minus 12, 0, 120. In float, they have a decimal place. So any number which has a decimal place is called a float. While a complex number is of the form a real number plus the complex part. So here 3 is the real part and 4j is the complex part. 2 is the real part, minus 2j is the complex part. Now, we talk about sequences. So strings are a group of characters. They can be alphabets, digits, or special characters. It is important to note that they are enclosed either in single quotes or double quotes, and we can't perform numeric operations on them. Keep this in mind. So, as you can see here as an example, we are using single quotes to write one string and double quotes to write the other. Mind you, we can use numbers inside a quote to store a string. Next, we have list. They're separated by commas and the items are closed in square brackets. They are primarily used to list something, such as list of numbers. Let's say 0, 1, 2, 3 till infinity. So here you can see we're using the square brackets to store a list and these are separated by commas. Next, we have tuples. Tuples are separated by commas and their items are enclosed in parentheses. This is unlike the list where values are enclosed in brackets. Also, an important point to note is that they are immutable, meaning once they are created, we cannot change their values. So here is the example of a tuple separated by commas and it is used using parentheses. Next, we have set, none, mapping, and dictionary. So set are basically using curly brackets and they are unordered collections of data. None shows us the absence of value. Mapping helps us choose multiple variables at once. So using the map function can help us use up to 3, 4, 5 multiple variables. Dictionary holds the data in pairs with key separated by colons and the keys primarily are strings. So as you can see here, this is the key and this is the value that it stores. Both are separated by a colon and both are under strings. And these aren't enclosed in curly brackets. Here is an example for none type and here shows us a set. Next, we move to mutable versus immutable data types. As I mentioned earlier, variables whose values can't be changed after they're created are called immutable and vice versa are called mutable. When an attempt is made to update the value of an immutable variable, the old one is destroyed and it is created by the same name in the same memory. So there are only 3 mutable data types currently in Python, which are list, sets, and dictionary. Rest, all including integers, float, complex, are immutable data types. Next, we talk about operators. So the first operator is the double equal to sign, which basically shows that if the two values are equal on both sides, then the condition is true, otherwise it is false. So one important point to note here is I will be talking that in later videos. When we are using if or else if, it is important to use double equal to signs to store the values. So here we can see let's say num1 is 4 and num2 is 5. So since both are not equal, hence this given statement is false. Not equal to is represented by this symbol and greater than less than are represented by the crocodile marks. So if the number on the left side, let's say 4, is greater than 5, that would be incorrect. So we would place false here. But on the same hand, if this was 5 and this was 4, the statement was true. We have greater than equal to and less than equal to. Next, we come to simple operators like addition, subtraction, multiplication, division. Then we have modulus. Modulus it helps us show the remainder. So over here, when we divide 13 by 5, we are given 2 as the quotient and 3 as the remainder, as 13 minus 10 is 3. Next, we have floor division. it helps us divide the operand on the left by the operand on the right and returns the quotient, but it removes the decimal part. It is also called integer division. So 13 by 4 will give 3 when we use floor division. And for exponents, we use this symbol right here. And for multiplication, we use the same symbol but only use once. And for exponents, it is used twice. So over here, num1 to the power num2 will be 3 raised to the power 4, which is the equivalent of 81. Next, we have logical operators. So there are three logical operators, and, or not. So if both operands are true, then the condition becomes true. But even if one condition is false, we print the false condition. Like here, one is true and one is false. So even if one false over here is false, we will print the false condition. When we are using or, if any of the two operands are true, then the condition becomes true. And mind you, let's say we want to find out between 1 or 2. So 1 and 2 both are true. So we will print 1 in that case. But in the same case, if we use 1 and 0, 0 is false. And we know that in AND, well, we have to check whichever one is false and we print that. So we will print 0 in that case. Next, we have plus equal to, minus equal to, multiplication equal to. This means x plus equal to y means x equal to x plus y. So let's say num1 is 10, num2 is 2. So num1 plus equal to num2 means num1 is equal to num1 plus num2. So 10 plus 2 is 12. Hence we get 12 here. Similarly, in multiplication, we see num1 times num2, which is 2 times 3, which gives us 6 right here. And the following is also applicable. Here is the modulus one, which gives us the remainder, and floor division, the exponential one. Next, we come to the precedence of operators. Now, the highest precedence is given to parentheses mentioned right here, which is evaluated within these brackets. Next comes the exponent and addition, subtraction, multiplication, and assignment operators. Now, it is important to note that these move, let's say we have a statement which has same operators such as plus and minus. Oh, right here. We go from left to right in a statement. And also, it is important to note that there is one exception here. We move from right to left in the exponential operators. As over there, we see from the right hand side. So if 2 raised to the power 3 raised to the power 2, then we will first move from 3 raised to the power 2 on the right hand side, which is 9, then 2 raised to the power 9, and finally calculate our answer. Let's look at one example here. We are first we see that there are parentheses given here. So we add whatever is given, whatever value is given in parentheses. Let's say if this was multiplication, so we would have done 24 first. Then we see as I told you, we move from left to right, and over here the divide symbol has a higher precedence than the plus one, so we divide first. That gives us 3.75 plus 11. That is equivalent to 14.75. Next, we talk about statement versus expression. A statement is a unit of code that the Python interpreter can execute, while expression is a combination of values, variables, and operators. So here is an example of a statement mentioned, where we are printing the cube of a number 4, which is 64. Now we talk about input versus output. The input function tells the user to enter a data, while output displays the data based on the input using the print command, which evaluates the expression before displaying them on the screen. Let's say here we take the input where we want to enter our name. Now we get a print command where we input our name. Then the program asks us to input our age. We input our age here. And so this one is the output where we are entering our name and entering our age, and this one where the input function is written shows us the input. This is the input and this is the output. So if we are printing, also an important point to note here is this part, this example right here is called string concatenation, which is basically the addition of strings. So if we are adding strings together, there is no space. So we have to be mindful of that. This is called string concatenation. Next, we talk about type conversions. There are two types of conversions, implicit versus explicit. It is when we convert the data type from one to another to get the desired output. Explicit happens when the programmer forces interpreter to convert data type into the program, while implicit is done automatically by Python and not the quota. So in explicit, we're converting one here, let's say from an integer to a string. While in implicit, what we're doing is the Python is automatically interpreting and changing it as one is a float and one is an integer. So when we take their sum, it is obviously going to be a float, and the type shown here is float as mentioned here. So that is an example of implicit, and this is an example of explicit. Now we talk about errors in debugging. When we identify and remove errors made in a line of code, also called bugs, it is called debugging. There are three different types of errors: syntax, logical, and runtime. Syntax is when not correct syntax is used, the interpreter shows an error. For example, we are printing hello world here, but notice that the string being printed doesn't have the symbol right here. Next is logical errors. It is when we get undesired output, but there is no termination of the execution of the program. For example, if we want the average of two numbers, let's say 10 and 12, and we are printing this, it will give us the output as 16, as we first need to take the sum of both of these and then divide it by 2 to get the average. Hence, we have to use parentheses. So this is an example of a logical error. Next is a runtime error. It is when the statement is correct syntactically, but the interpreter cannot execute it. They do not appear until after the program starts running or executing. For example, if we divide any number by 0, it will give a runtime error because it is not defined. I hope this video helped you, and see you in the